In this video, I'll go over the derivative of a function. Let's start with the definition. The derivative of the function f of x with respect to the variable x is the function f prime whose value at x is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, provided the limit exists. An alternate formula for the derivative is, given z is x plus h and h is equal to z minus x, we have f prime of x is equal to the limit as z approaches x of f of z minus f of x all over z minus x. Let's review again. What is the derivative? It's the slope of the tangent line to the curve at the point x comma f of x. It is also considered the instantaneous rate of change of the function at a value of x. We have lots of different ways of notating the derivative: f prime of x, y prime, dy dx, df dx, and d by dx of our function f of x. One more time, you can find the definition of the derivative, again noting the different notations I just mentioned. Again, f prime of x is equal to d by dx of f of x, or we can write that as equivalent to df dx. And again, one last time, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's discuss differentiability. A function is not differentiable at x equals a if a is not in the domain of f, if f has a discontinuity at a, if f has a vertical tangent at a, and if the graph comes to a sharp point at a. Definition: if the limit f prime of a is equal to the limit as x approaches a of f of x minus f of a all over x minus a does not exist, that is, the function f prime of x is not defined at x equals a, we say that f is not differentiable at x equals a. And similar, if there's no problems, this value is defined, we say that f is differentiable at x equals a. Let's start looking at a few examples on now actually finding the derivative. All right, using the definition, find the derivative of f of x is equal to x squared plus 2x minus 3. So, writing our definition, we have the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, we were given our function, so plugging this all in, we have this equal to the limit as h approaches 0 of x plus h squared plus 2 times x plus h minus 3. Subtract our original function f of x, so don't forget those parentheses, x squared plus 2x minus 3, close parentheses, all divided by h. From here, we just have a lot of algebra to simplify, so this is going to be equivalent to the limit as h approaches 0. Don't forget, x plus h squared means x plus h times x plus h. Foiled out, we would get x squared plus 2xh plus h squared. Next term, distribute the 2, plus 2x plus 2h minus 3. And finally, distributing that negative, we got minus x squared minus 2x plus 3 all over h. After that, I see a bunch of stuff I think that's going to simplify for us. Let's see, I got an x squared and a negative x squared disappears. I got a positive 2x and a negative 2x, and that goes away. And lastly, I see a negative 3 and a positive 3. So, writing out what is left, I got the limit as h approaches 0 of 2xh plus h squared plus 2h all over h. I can see in my numerator I can pull out an h from everything, so I have the limit as h approaches 0 of h times 2x plus h plus 2 all over h, and I see my h's can cancel out there. And so now I am left with the limit as h approaches 0 of 2x plus h plus 2. Now that everything is simplified, I can go ahead and plug in 0 for h, so I have 2x plus 0 plus 2. And finally, my final answer for the derivative will give me 2x plus 2. Let's take a look at example number 2. Let's differentiate f of x is equal to x over x minus 1. Again, I'm going to go ahead and use that same definition of the derivative. We've got the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, plugging in with our function, I now have the limit as h approaches 0 of x plus h over x plus h minus 1 minus the original function, x over x minus 1, all divided by h. All right, you can see this is a little messy. As I always like to say, we have a baby fraction inside a really larger, bigger fraction. And I can't just go ahead and plug in 0 for h right away, right? I need to do some algebraic manipulation. So what I like to do is get rid of that baby fraction, and I do that by multiplying by the common denominator. In our case, I'm going to need to multiply this entire thing by x plus h minus 1 times x minus 1. All right, on the next line, I have the limit as h approaches 0, and once I distribute in the common denominator, what will I have left? So on the first fraction, my x plus h minus 1 is going to cancel out, so I'm going to be left with x plus h times x minus 1. And then on the second term, so then I have my minus sign. My x plus 1s are going to cancel out, so I'll be left with x times x plus h minus 1. And all of that is going to be divided by h times x plus h minus 1 times x minus 1, all in the denominator there. All right, so now we took care of the baby fraction and the big fraction, and now we just have a lot of algebra left over to simplify. So on the next line, this is going to be equal to the limit as h approaches 0, and I got a bunch of foiling and distributing to take care of. So what am I going to have? I'm going to have x squared minus x plus xh minus h. On the second term, don't forget your negative also needs to distribute with that x, so I'm going to have minus x squared, a minus xh, and a plus x, all divided by my denominator. And my denominator I'm just going to leave and hopefully aim to cancel some items out in just a second. All right, so let's see what's happening in the numerator. I have a positive x squared and a negative x squared that will simplify. I have a positive xh and a negative xh that will simplify. And what else did I say? Last item, I have a negative x and a positive x that's going to simplify. All right, so let's put it all together. What is left over? In the numerator, I see just a negative h. And then I'm going to rewrite my denominator one more time. And then I can see, finally, I have an h on top and an h on bottom that's going to cancel out. And I can rewrite one last time the limit as h approaches 0 of negative 1 over x plus h minus 1 times x minus 1 in the denominator. And now at this point, I can go ahead and plug in 0 for h. And I'm going to have negative 1 over x plus 0 minus 1 times x minus 1. And when I simplify that out, right, I can ignore that 0, and all that's left is -1 over x minus 1 times x minus 1, which I can rewrite as x minus 1 squared. So there we go. My final derivative for this problem is just -1 over x minus 1 squared. All right, let's take a look at one final example. Let's find the derivative of f of x is equal to the square root of x. All right, just to change it up a little bit, I'm going to go ahead and use that alternate definition that says f prime of x is equal to the limit as z approaches x of f of z minus f of x all over z minus x. And now plugging in, we have the limit as z approaches x of the square root of z minus the square root of x all over z minus x. Again, we need to do some algebraic manipulation before we plug in as z approaches x, and so it's a little backwards on the manipulation for maybe what you might be used to at pre-calculus. I'm going to still use the idea of multiplying by the conjugate, but now using the numerator instead of maybe what you're used to doing in the denominator. So I'm going to multiply top and bottom by root z plus root x, and repeat again on the bottom. Alright, and from here I'm going to FOIL and do some algebra. Let's see, I have the limit as z approaches x. Alright, when I FOIL my numerator, I'm going to be left with just z minus x. And then on the bottom, instead of actually FOILing, I'm just going to leave it side by side because we are going to have some things cancel out, of course, on us. And so I can see now that I have a z minus x in the numerator and a z minus x in the denominator. So we can cancel that out, and now I'm just left with the limit as z approaches x of 1 over root z plus root x. And now we can go ahead and plug in as z approaches x. This would give me 1 over root x plus root x. And my final answer for my derivative is 1 over 2 times root x.